Okay, huh? So class, this is not part of the answer, but I would like to talk about when I have a rational function like this, correct? Still remember we talk about domain is very important. Yeah, so I usually will tell myself that I try to get what are the value of x. Okay, we know that the domain cannot be equal to 0. So it means that sin x cannot be equal to -1. So can you tell me what are the possible value of x? So if I say x cannot be equal to 3 pi by 2, do you know how Miss Do get this answer? X cannot be 7 pi by 2. X cannot be 11 pi by 2. Do you know how I get all these answers and so on and so forth? Do you know how I get this answer? Hmm? Yes, by the quadrant. Still remember, we have the unit circle. This is the circle, the radius is 1 unit. And here, if the angle is on this line, it means 0. If you go second round, it will be 2 pi. Then third round, it will be 3 pi and 4 pi and so on and so forth. Correct? If the angle is along here, the angle turn until here. So this will be pi by 2, correct? And this point, the coordinate is 0, 1. And we know that cos pi by 2 is 0 because the y coordinate represent pi by 2. And this point, the angle will turn from here to here. So the angle is 3 pi by 2. So the coordinate here will be 0, -1. That's why sin 3 pi by 2 will give us -1. So if you go second round, it will be 3 pi by 2 plus 2 pi. So it keeps going on and on. So there are a lot. So if I sketch this graph, there is a lot of vertical asymptote. You can try. Are you clear? So when come to trigo, right, you have to be very careful. The answer is not just a single answer because it keeps repeating the cycle over and over and over again. Yep. So take notes of that. Okay, so for this question, what you are supposed to do is you are supposed to use cosine rule. You are supposed to use quotient rule. Okay? So I'm going to show it to you how I get. So dy dx equal to, up here is your u, down here is your v. Yep. So v, there are 2 terms. So it's good to put in bracket. Okay, you differentiate cos. What do you get, Alicia? Alicia, you integrate, you differentiate cos, what do you get?
Negative sign.
Thank you. Negative sin x. And you differentiate x, you get 1. So we don't write, huh? Take away u v prime. Okay, you differentiate 1, you get 0. You differentiate sin x, you get cos x. You differentiate x, you get 1. Divide. by 1 plus sin x, the whole thing squared. So equal to, you expand negative sin x plus, minus sin x, the whole thing squared, minus cos x, the whole thing squared, divided by 1 plus sin x, the whole thing squared. So what we can do is we can take out the negative. Okay, so now I have sin x plus sin x square plus cos x, the whole thing squared. We call it sin square x plus cos square x. Okay, we know that identity. Still remember your identity? Sin square x plus cos square x. The answer is 1. So we replace this whole thing by 1. Okay, so we have negative 1 multiplied by sin x plus 1 divided by 1 plus sin x, the whole thing squared. So this can be simplified. The power here become 1. So end up our dy dx is negative 1 divided by 1 plus sin x. So dy over dx equal to 0 means negative 1 over 1 plus sin x. So we get negative 1 equal to 0. So this is impossible. So this shows that there is no horizontal tangent. Clear? Hello? Okay, huh? Okay, so for what value of x is fx undefined? That means we are talking about not part of the domain. So therefore, I say cos x cannot be equal to 0. So if you go back to the circle that we are talking about, x cannot be equal to which one? Pi by 2 and 3 pi by 2. Anyone have this issue? Do I need to show you how I get the answer? So this one you must jot down. This thing you must jot down in your notes. This thing must jot down in your notes so that whenever you want to use it, you can use it. Okay, so I believe everyone know this. Okay, now, because if you use your scientific calculator, correct, it gives you do sin inverse x, sin inverse 0, cos inverse 0, correct? If you put it cos inverse 0, the calculator will just give you one answer only. The rest of it, you have to look it for yourself. Are you clear? Hello? Okay, done, Johnson, you understand or not? Trying to, what do you mean by trying to, Johnson? You cannot say by trying to, you have to. This is no choice. You understand? Carmen, you understand? You didn't answer me. I missed. I won't be able to help you. Okay. So this is based on the unit circle. At this point, and at this point, the x coordinate is 0. So because x represent cos, so this at this point the angle is pi by 2. At this point, the angle is 3 pi by 2. The x coordinate is 0. So this we read like that, cos 3 pi by 2 equal to 0. Therefore, the angle is 3 pi by 2. Are you okay? Okay, so number B. So find the position and the nature of the stationary point on this interval. So I have to write my fx as this form. Yep. So I want to find the stationary point. I have to get the gradient function first, f prime x. So bring down the power, copy down the whole thing. Power, take away 1. Differentiate cos, you got negative sin. Differentiate x, you get 1. Okay, so now you simplify by multiplying negative 1 with negative 1. So I have positive, so I have sin x divided by cos x, the whole thing squared. I say this is equal to 0. So therefore, sin x equal to 0. Okay, so we go back to the circle again. Sin x equal to 0 happen at this position and this position, correct? Because the x coordinate, the y coordinate at these 2 points is equal to 0. So therefore, I say x equal to 0, the first round. Then x equal to pi. Then x equal to 2 pi. Okay, now for this one, in order to know the nature of the stationary point, what we should do is we should draw the sign diagram of f prime x, correct? Okay, so now draw the sign diagram of f prime x. You mark down the domain, and the domain, the limit of the domain is happen to be the stationary point as well. So in this case, it will be very hard for us to find just by determining the sign. So what we need to do is you can do by sketch the graph. Okay, so this is a technique. You can use your GC. So this is a technique. So now you go to your GC, you key in y1 equal to 1 over cos x. Please. Okay, then you go to your window. Okay, if our window, correct, if our x minimum, correct, if we put as 0, correct, then you will start from the stationary point. So we won't be able to know whether it's a local minimum or a local maximum. So what we do is our x minimum, we put a bit less than 0. So we put negative. For example, I put negative. Okay, by the way, pi is 3.142, correct? Okay, so we put a bit less. So we put negative 0.5. Okay, our x maximum, we don't put 2 pi. 2 pi is approximately 6 point something. So we, instead of put 6, we put 7. Can I not? You understand what I mean, so that I can see the turning point. Okay, after I have done that, I go to zoom. Yeah, select zoom fit. Okay, you will realize that your your Y maximum is quite big, or your Y minimum is quite big. Am I right? Am I right? Amir? You can't really see the turning point. You can't really see the turning point. The graph will go like that. You see the graph go like that. Very near like that. And you know you got one horizontal asymptote and the other one is here. Then the other one go like that. Then the other one go like that. Am I right? Hello? So what you need to do, you cut your Y, you go to window again. You cut your Y minimum to a bigger number, you cut your Y maximum to a bigger number. So this is your Y equal to fx graph, plus. So if you see Y equal to fx, this is going up, correct? This part is also going up, correct? So we know that there is an asymptote, pi by 2. So you have to mark down there, 3 pi by 2. Hello? When you draw your sine diagram. So this is positive. This one is positive because the fx graph is going up. And this is negative. And this is negative. So actually here, this part at 2 pi, correct? It is going up. Actually, if you extend a bit, this is positive. Hello? And this one, this is negative. You get what I mean? So therefore, okay, when x equal to 0, pi, and 2 pi, correct? Your fx will be equal to 1, -1, and 1. Okay, so therefore, I have this point 0, 1, and 0, 2 pi, 2 pi 0, local minimum. And pi -1, because cos pi is -1. So 1 divided by -1, you got -1. Is
Miss Do, don't you have to find the Y values for the...
Yeah, I find already what there. The Y value here
Oh, yes.
is a local maximum. See or not? I didn't show the working how I find it only. So, but if you just draw this sine diagram, you won't be able to see because we don't know what happened to this part. So you definitely have to use by the help of the graph. So that's why I don't put here exactly 0 and here 2 pi. I put a bit less so that I can see the turning point. You get me? So you must learn how to use your graphic calculator to help you to solve trigo problem. If not, you need to know a lot of things about trigo. Can I move to the next one? Yeah, I move to part C. Okay, I'll move to part C. Okay, they asked me to prove that fx plus 2 pi equal to fx. So what I need to do is, I will start from the left-hand side. Whenever you do proving, correct, for max, correct, either you start from the left-hand side to the right-hand side or right-hand side to the left-hand side. Definitely in this case, left to right is much easier because the angle given is x plus 2 pi. Okay, so now fx plus 2 pi. This is the angle. So the formula is 1 over cos of the angle as x plus 2 pi. Okay, when you talk about trigo, correct, you are going in cycle. One cycle is 2 pi. So if I have come to this angle, my angle is go like that and come back. You see, it come back to first quadrant. Okay, you look at here. I start with my angle theta. So you see this is theta. So the second angle, I come back here. So this come back to theta again. So this particular angle, we call it theta plus 2 pi. So that means it come back to the same quadrant. So we will say that cos theta plus 2 pi is the same as cos theta. It come back to the same position A here. See or not? So this is equal to, this is the true fact that every one of us must know. Even sin also the same. This is the same as 1 over cos x. So this is my fx. So geometrically, it means that this function has a period of 2 pi. One cycle, complete cycle is 2 pi. It come back to the original position every 2 pi. So if 4 pi also the same, 6 pi also the same. Every cycle is 2 pi. That's it. That is called the geometrical significance of the result. Okay, can I move? So I also have like that. Sin theta plus 2 pi is equal to sin theta. The rest of it, when we see, then only I tell you. I try not to give you too much thing. You get very, that one. So just remember, one cycle, 2 pi. After 2 pi, it come back to the original position. So there is no change. Okay? So let's talk about part D. Okay, when I solve part D, I have to be very careful of the vertical asymptote. So when I do this question, I will prepare my axis first. I will draw all the vertical asymptote based on my answer from part A. You see or not? Pi, 3 pi by 2. Okay? So how am I going to talk about the rest? Yeah? So you have this. Yeah? So the important thing here is here. Cos cannot be 0 because it's your function is and here. Yeah. So this is the one. So pi by 2, 3 pi by 2. Go one round, pi by 2 plus 2 pi. This is 5 pi by 2. All right. So now here I got 1, to 3 vertical asymptote. Pi by 2. So I put a dotted line before I sketch the graph. Okay. 3 pi by 2. Another vertical line, dotted. Then 5 pi by 2. Are you okay? Then the other one will be, because angle when you go in an opposite direction, it will be negative. So another vertical asymptote will be negative pi by 2. Okay? So it will be negative pi by 2 here. So that means you are going to sketch the graph within this. So then only you get into your graphic calculator and put your x minimum, x maximum at that, then you sketch the graph. Are you clear? So when you talk about trigo sketching, if there is a vertical asymptote, you better put it down. Can you understand? Okay, now you try to sketch the graph. I believe the graph you have is will be like that. Just now we know the local minimum already, correct? Is this point 0, 1. And here there's a local maximum here. And here is pi and negative 1 here. Okay, and another one will be here. Two pi and 1. Are you okay? So first, get your vertical asymptote first. So they can have many vertical asymptotes. So actually the graph will repeat itself like that. It will go on repeating itself, you see? From here to here is 2 pi. So 2 pi is one cycle, you see or not? After that, you get into another cycle. So that is the property of trigo function. Any question? No. Okay, if no, okay, you will try the inflection point one. Usually, you see trigo, we hardly will ask you inflection point also, because the inflection point, all right, is repeated many. And you look at curve property, I definitely won't ask you on curve property on trigo. So when talk about graph, right, stationary point or inflection point, right, usually we will not ask you. Like for example, this case, right, there is no inflection point. Why? Because the shape of the graph changes at the vertical asymptote. See or not? So if the question asks, there is a changes of the shape of the graph, why there isn't a vertical, why there isn't an inflection point? Because the inflection, the shape of the graph changes at the vertical asymptote. So that's why it's undefined. That's why there is no inflection point. See or not? Okay? No question? Okay, so tomorrow I will talk about the kinematic part already. Yeah. So by tomorrow, I should be able to finish chapter 3. Then Thursday, I will go into chapter 4. And that's why I say in 2 weeks' time, we should be able to have our SAT4. Definitely it's before you go for your break. Okay or not? Thank you, class.
Thank you. Bye bye.
Thank you.